Hello, ladies and gentlemen, and welcome to the last lesson in Math 20-3. I guess the last unit, I mean to say, in 20-3. This is the first lesson of Chapter 5. There will be 4 lessons for it. And this first lesson is on broken line graphs. So the unit is called statistics. It's called that because we're basically graphing a bunch of things and then taking information from those graphs. So that's what we're going to start with today. We're going to start with a graph called a broken line graph. Now, there is some information about broken line graphs here that I want to read through. It's good information for you to know. If this was something that you wanted to take notes on, you could take notes on it. First of all, let's read through this bit here. So in this section, you will learn about broken line graphs. A broken line graph shows information by plotting values and joining them with line segments. The title of a graph and the labeling of the horizontal and vertical axes tell you about the data shown. If you are drawing the graph, you have to decide what variables to display on each axis, as well as a scale for them. I'm going to talk about all this in a second. The independent variable goes on the horizontal axis and the dependent variable goes on the vertical axis. Okay, let's talk about what all that means. Basically, here's an example. So this is an example of a graph. It's the average monthly snowfall in Regina, Saskatchewan. So the title is very important. You always have to have a title. You always have to label each axis. And so in this case, this axis is the S-axis. It's also known as the Y-axis. And down here we have the M-axis, which could also be referred to as the X-axis. Okay. Axis just means it's the this line, the horizontal line. So the x-axis is this horizontal line, and the y-axis is this horizontal line, and it represents certain things. So the y-axis, or the s-axis in this case, represents the amount of snowfall in centimeters. And I want you to notice that what they do there when they're labeling this is they include the unit. Okay, it's the title of it and then the unit in centimeters. And then down here, it is the month. And of course, the unit is month anyways. And so that's why the y-axis is labeled S for snowfall and the x-axis is labeled M for month. So we've got all that information labeled, and then you can see we've got our points plotted as we go along. So like the first point is in January, there was between 15 and 20 centimeters of snowfall. This point right here, where would that be? Well, if this line is 15, then this would be 16, 17, 18, 19, 20. And so the point here is at 19 and a half. So I would say something like in January, there was 19.5 centimeters of snow. Okay, and so that's how you read the graph. It's a broken line graph. The line it connects both points here, or all the points, with a dotted line or a broken line. It's just not a straight line. There's a lot of really good uses for something like this for showing different data, and we will show different data based on these things. But what else did we say here? So the horizontal and vertical axes, which variables go on. So you have to pick the variables. You pick the S or you pick the M. And then you also have to pick the scale. And so depending on what your data is, the scale that they've chosen, it goes from 0 to 5 to 10 to 15 to 20 to 25. But each dash is 1 centimeter. And they've drawn the graph to be able to show you 1 centimeter at a time. Now, if the snowfall went from, let's say one month had 100 centimeters of snowfall, which would be a lot, but let's say that it did, then we might have to adjust the scale to fit the graph on this axis here, okay? And so you pick the scale. On the bottom, the x-axis or the m-axis, the scale will be just 1 month at a time, basically. So January, then February, then March. And again, you pick that scale, okay? And then it says the independent variable goes on the horizontal axis and the dependent variable goes on the vertical axis. Well, the independent variable is on the horizontal axis, that is the x-axis. So independent. And an independent variable is basically a variable. It's one of the things we're considering when we're graphing that does not rely on the other thing. It's not dependent on the other thing. And so time is usually an independent variable. Month is a unit of time here, and time just keeps going forward no matter what. There's nothing else that changes how time goes forward. It just keeps going on and keeps going on. And so it's completely independent of anything else that might change it. Whereas snowfall on the y-axis here would be our dependent variable, and the dependent variable is the thing that could change month to month. So the amount of snowfall varies, okay? It varies. Whereas the time or the independent variable just keeps on marching on no matter what happens, and it's not dependent on anything. I hope that explanation makes sense. If you need a better explanation of independent and dependent variable, Google it. I'm telling you, you will find a whole schwack of different explanations of what independent and dependent variable are. But that's a good way for you to learn it if this didn't give you a good enough explanation. But that's generally what we're talking about in this section here, okay? There's like a definition of a broken line graph here. It's a graph that uses points joined by line segments to display data. And so that's what we're talking about. Another point about broken line graphs is that they are useful for showing a trend over time. So if I've got a trend of something happening, we can see it very, very easily with a broken line graph. They can also be used to compare sets of data using multiple lines on the same graph. So sometimes we'll have a line graph. I don't have one in example 1 here, but sometimes we'll have a line graph that has more than one line on it, and we can use it to compare. So for example 1, I have the same graph that I was talking about, the average monthly snowfall in Regina, Saskatchewan. And here's some examples of questions that you will be expected to answer with this graph. Okay, so it says the graph below shows the average snowfall in Regina, Saskatchewan by month. We've gone through the graph. Question A says, what month has the highest average snowfall and how much snow fell that month? Well, we have to look at the graph. The highest snowfall would be the one that has the greatest number here. So if I look, this point right here is the point that is the highest up on the y-axis or the s-axis. December had, it looks like 21 centimeters of snow. So I'm going to say December, and I'm going to say 21 centimeters. That one's pretty, questions in this unit, guys, are pretty easy to answer if you understand what a graph is. And so let's continue answering questions like that. So B says, during what 3 months is there no snowfall in Regina? Well, looking at the graph, I've got no snowfall in June, no snowfall in July, and no snowfall in August, which makes sense because those are the summer months. So I'm going to say June, July, and August. And finally, C says, during what month is the average snowfall approximately twice as much as the average October snowfall? Okay, well, let's see here. October, we have our point here. So if I go to my s-axis, it's right here. It's 5, 6, 7 centimeters. So approximately double 7 would be 14. So if I look here, it looks like February has approximately 14 centimeters of snow. And also, if we go over here, it looks like November has just under that. So I might be inclined to include that in this question as well. What month is the average snowfall approximately twice as much? So I'm going to say February and November, because those are both approximately double. I hope that makes sense. I will have another video for this section coming up in a second.